Alright, in this video we'll take a quick look at some cool debugging tips in IntelliJ. Now I suspect that these should also work in other JetBrains IDEs, but I haven't actually tested that. Okay, so let's jump straight in. So here I have a basic Java 22 project. The code is really just junk code. You can see that we're creating some objects, we're printing some stuff out, we're calculating some values, and we're doing a bit of conditional logic, and we've got some other methods here. You can also see that there's a few other classes other than the main one. The code itself isn't particularly important, it's really just to show you the features of the debugger. So knowing some of these tips and tricks of how the debugger works can really make life easier when you're trying to get to the bottom of a nasty bug. So tip number one is the simplest of all, is simply the shortcut to run the debugger. The shortcut for Mac is Control-Shift-D. When I run that, you can see that it starts to run the debugger and jumps to the first breakpoint. Now this won't necessarily run the file that you've got open, but rather run the last run configuration you had. So keep that in mind. Alright, so tip number two is reset frame. Now as the program executes, frames are added to represent the levels in the call stack. And if you skip too far, you can just reset the frames. So let's take a look at that in action. Let's run this code. And you can see that it hits the first breakpoint. Let's step over that and let's step into this code. Now you can see that on this call stack here, we have an extra frame. And if you decide that you've come into this method, but actually you really didn't want to, you want to go back to where you were, you can simply do reset frame. And when you do reset frame, it's gone back to here. Let's try that one more time. So we go into the method here by doing step into. If you decide that you've gone too far and actually you want to step back, you want to step out of this method back to the call site, you simply click this reset frame icon. Alternatively, you can right click and do reset frame. And as you can see, it goes back to where you were. Now this is of course incredibly useful, but one thing you do need to be aware of is that this will not reset any global state that's been modified. So if you go too far, you go into that method, it modifies some global state, you reset frame, the global state itself will not be reset to as it was before you called that method. Alright, so tip number three is conditional breakpoints. Now you can do lots of cool things with breakpoints. So we have a breakpoint set here. Now if we right click that breakpoint, we can actually set a condition under which this breakpoint should execute. So we could say, for example, something, which is this variable over here, dot contains hello. If this condition evaluates to true, that breakpoint will be hit and will suspend. If it doesn't, the breakpoint won't be hit. So let's just see that, and you can see that that's symbolized now with a question mark because it may or may not be active. So let's actually debug this code and see what happens. So I hit debug and you can see that it hits the first breakpoint. If I click resume program, it should run to the next active breakpoint. I do that and you can see that it's hit that breakpoint. It's hit that breakpoint because the something variable does contain the word hello. Okay, so we can see that that breakpoint worked. Now if I just kill that, if I change the condition on this to say ABC, now we would hope that it wouldn't hit that breakpoint. Okay, so we run the debug program again and we resume the program, and you can see that it's jumped way past that breakpoint there because that breakpoint is now effectively not active because of this conditional statement. All right, so that's conditional breakpoints. If you want code to execute and you only want it to stop under certain conditions, for example, if there's some looping and iteration going on and you only want to stop when particular values and conditions are true, you can use conditional breakpoints. Alright, so the next tip is about watchers. So when you're debugging your program, sometimes you're particularly interested in kind of some particular expression or particular variable, and it may be nested, and so it can be a bit of a faff to try and view it in this window here. So let's say we are interested in a particular variable. You can go ahead and add it to watchers. So say for example we're interested in I, well you can right click that and say add to watchers. Okay, and now you can see that there. Now, given that the execution point is just here at line 8, we haven't got to I yet, so you can see that it says I cannot find that variable. Let's try and find some other variables. Let's say we're interested in this expression here. So again, we can add that to watchers. Okay, so you can see that at this point in the execution, which is right up here, the name is John. Now, as we progress through the code, you can see if there's any changes to these watched variables. So if we get down to where we see I, you can see that I now has a value. You can continue to execute this and you can see that I is changing as we are executing through the code, and John remains static because it's a fixed value and we're not modifying it. Now, as I said, you can also find these values by looking through here. So you can see I here, but it's quite handy to set watchers for particular expressions or things that you're interested in. Now you can also add expressions here. So for example, if you want to have a value that checks whether I is equal to a particular value, we can say I equals say 2, and then we can click this little plus icon here, and that gets added to the watch. So now this isn't just a variable that you're tracking, but this is rather an expression, and the result of that expression is false. Now this really becomes more useful when you have nested types and that kind of thing, where you are constantly kind of expanding bits to get to the data that you're interested in. You can just set a watcher for it and see it in action right at the top here. And you can also do expressions like we've done here and add them to the watchers. Alright, so tip number 5 is force return. Now sometimes you have a method and it's returning a particular value, but you actually want it to return something else to get to the nub of the issue that you're trying to investigate. So it's quite handy if a method was to return a particular value. Now normally you need to set that up to return that value, or you need to comment the code and hard code another value for it to return that value. So let's take a look at an example in action. We've got this method here called get remaining life expectancy. It just returns 100, taking away the person's age. Now in the actual execution, if we run it, we'll see what this results in by putting a breakpoint here. So if we run that and we resume, we can see that x equals 80. But if we wanted to see what happens to the program if x was to return, say, 20 or 25, we can actually do that. If I stop this and run it again, let's get to the point that we're interested in. So now we're here. Now this we know is going to return 80, but say we wanted it to return 20, you can simply go to the stack frame here and say force return, and it says what value or expression do you want to return. Now we could put a different expression in here, but just to keep it simple, we can say 20. All right, let's do that. And if we step over this line of code, we can see that x now equals 20, and we can see that there too. Now that's useful when you want to test what your program does when a method returns a particular value or expression. Okay, so the next tip is to get back to where you were. So let's just run debug again and get to somewhere interesting in the code. So say we are here. Now you've gone off and you're looking at your Gradle file, you're looking at your settings, you're looking at some thread class and employee class, and you think, I've still got my debugger running and I'm still interested in where we were. Now the way to get back to where you were is to simply click show execution point, or there's a shortcut for it as well. So if I hit that, you get back to exactly where you were. So that's just a quick tip which can be quite handy when you're navigating around your code. All right, so the next tip is kind of related to the force return, where you change the return value of a method. You can actually change the value of a variable during execution as well. So we have this type here called John, which is a student, and the name is set to John, of course, and the major is set to computer science. If we want to change this, we can simply right click and say set value, and we can change that to something else like physics. Okay, and that's modified the value. So as we step through the code, we can see that that retains that value and it stays as physics. So often when you're playing with different values and you're trying to isolate a problem, it can be really handy to just change your value here rather than to go back to the code or your test and change the value there. All right, so the next and final tip is to log values instead of pausing execution on a breakpoint. Now we've got breakpoints here. As you can see, some of these are conditional, some of them are just kind of typical breakpoints. If I right click, they just look like normal breakpoints. If you wanted to add a breakpoint where you don't actually stop the execution, but rather you log something interesting at that point, you can right click on your breakpoint and click more, and you can add more config here. We've got an example here. So if I right click this one, you can see that the breakpoint is enabled, but suspension or suspend is unchecked. That means it won't actually stop at that breakpoint. Now, instead of that, we just want to log a particular value when it reaches this breakpoint. And the thing that we're logging, if I go to the beginning, is we just say this is a pointless number, and then we log I plus 100. You can pretty much log anything as long as it's available in the context of where this breakpoint exists. And you can see that when you do that, the breakpoint becomes yellow rather than red. So again, no logging has been added here. It's all done via the breakpoint, which you can see here. So let's resume this code and see if at the end we actually get those outputs. So you can see here when the code hits that breakpoint, the yellow breakpoint, it doesn't actually stop the execution, but it just does this nice logging. So instead of stopping and starting your program, you can just add logs and see what the values are at the end. And that can really be quite handy and stop you having to litter your code with system.out.println or other logging statements. All right, so that wraps up our tips. I'm Saeed, the Codogrammer. Let me know what you think in the comments below. And if you do not want to be the last to know about important AI, tech, and programming news, then be sure to hit subscribe. Thank you for watching.